Hi, I'm Professor Goins, and welcome to the Math Professor's YouTube channel. If you look for videos explaining topics in college mathematics courses, go ahead and hit the subscribe button because you're in the right spot. That said, let's get into the current video. In a previous video, I introduced what's called a Weierstrass substitution, and I didn't do any actual substitutions with it. I just showed you how to do all the setup. The idea is everything starts from this right here. T is defined to be the tangent of x over 2, where I'm starting with an integral that has x as my variable and all the components are trig functions. And the idea is I can take that trig integrand and I can convert it to an algebraic integrand using this idea, using this substitution. From that, what I did is I showed you where dx, how that's related to dt, how cosine, sine are related to the variable t, and of course all the other remaining trig functions are just ratios of these. Now let's go ahead and do some examples of integrations. And let me go ahead and start with looking at the integral of 1 over 1 plus cosine. All right. I've computed this before in a video where we used what was called a Pythagorean conjugate. Here's an alternative way to do it. Notice that the integrand here has the variable x and it has cosine in it. I'm going to replace cosine with this expression and I'm going to replace dx with this expression. Let's see what happens. Integral 1 over 1 plus cosine is 1 minus t squared over 1 plus t squared multiplied by dx, which is 2 over 1 plus t squared dt. If I multiply those two together, I'm going to get 2 over, now I take 1 plus t squared and distribute that through. Of course, 1 plus t squared times 1 gives me 1 plus t squared. And then 1 plus t squared times this rational expression here, the denominators cancel, giving me plus 1 minus t squared dt. In that denominator, the t squareds cancel, giving me the integral of 2 over 2 dt. Of course, 2 over 2 is 1. Integral of dt would be t plus c, but then converting that back to the original variable, this gives me tangent of x over 2 plus c. All right. Take a look at another example. Okay. Let's look at the integral of cosecant of x dx. All right. We've done integral of cosecant other ways. Sorry, I dropped a marker there. We've done integral of cosecant other ways. Let's see if it is advantageous to use a Weierstrass substitution. Well, cosecant, of course, is the reciprocal of the sine function, so 1 over sine x dx. And now if I want to go through and use this substitution, I'll replace sine of x with this expression. That'll give me 1 over 2t over 1 plus t squared. And then dt is 2 over 1 plus t squared, and then dt. Okay? Just like we did over here, let's multiply those together. This is going to give me the integral. On the top, I'm going to get 2. And then here, 1 plus t squared is going to cancel with that 1 plus t squared, which is going to give me 2t dt. And then I can cancel the 2's. That's going to give me integral of 1 over t dt. And then, of course, this is going to give me the natural log of the absolute value of t plus c. And then, of course, I can replace t with tangent of x over 2, giving me the natural log, absolute value, tangent of x over 2, and then plus c.